Quadratic function and its inverse. A quadratic function is represented by a parabola. It is a many-to-one function. This is the graph for y equals x squared. We can reflect this graph about the line y equals x to find its inverse. The inverse graph will not pass the vertical line test as it is a one-to-many relation, and so it is not a function. We can find the equation of the inverse algebraically by swapping the x and y in the formula, so we get x equals y squared. Now, make y the subject of the formula by taking the square root on both sides. You get y equals plus or minus square root of x as the equation of the inverse of y is equal to x squared. We can restrict the domain of the quadratic function to only the positive x values. For x greater than or equal to 0, the graph will have only y values on the positive y-axis. Now, the inverse of this restricted graph can be drawn using the y equal to x line. The y values of the inverse will be restricted to only positive values. This is the graph y is equal to positive square root of x for values y greater than or equal to 0. Using the vertical line test, it's clear that this inverse graph is a function. If we choose to restrict the domain of the quadratic function to only negative x values, so x less than or equal to 0, we find that the inverse given by the function y equals the negative square root of x. Example 1. Sketching an inverse quadratic function. Given f of x equal to minus a half x squared and x greater than or equal to 0, determine the equation of the inverse of f of x and sketch f of x and its inverse on the same set of axes. To find the equation of the inverse, we can write the function as y equals minus a half x squared and swap x and y. So x equals minus a half y squared. To make y the subject of the formula, you can multiply both sides of the equation by minus 2, then take the square root of both sides. You get y equals plus or minus the square root of minus 2x. This is restricted to positive y values. To sketch f of x, you know it is a parabola with a turning point 0 and 0. You can calculate corresponding y values for x equal to 1, x equal to 2, and x equal to 3 by substituting these values of x into the equation and finding the function values. Use symmetry about the axis of symmetry y equals x to sketch the graph of the inverse of f of x. You can check the inverse graph by looking at some points on the graph. For example, 2 and negative 2 on the function will be negative 2 and 2 on the inverse. Look at the graphs of the function and its inverse. You will notice that they are both functions. The restricted domain of f of x led to a restricted range for the inverse function.